Hello, this is the generally approachable Sudoku for the 25th of March 2024. It's Lockout Lines by Clover featuring lockout lines, of course. So yeah, some very interesting looking symbols today. Let's take a look at the rules. Normal Sudoku rules apply, so place the digits 1 and 9 every row, every column, and every 3x3 box. There are some lines in the grid with diamonds at each end. So for each line, digits in the two diamonds must have a difference of 4 or more. Well, that's not really relevant now because those digits are already given to us, so they, by definition have to be at least 4 or more, so we don't need to worry about that. In addition, digits along the line must not be in between the values on the diamonds. So for example, those digits cannot be between 5 and 9. So this digit, for example, cannot be a 6. Well, it can't be a 7, I guess. It can't be a 6 by the box, but it can't be 7 because 7 is between them. So it must be outside. You could have 1, 3, and 4. These are all valid digits to place there. But yes, nothing between them. Now, see, I don't actually know if, digits may be in the range. All equal, right, sorry. So digits along the lines must not have values between or be equal to the values in the diamonds. I can't really read there, but yeah, so something like this is not valid either because this digit cannot be equal to any of those. So it can't be between like a 4, it can't be exactly that digit, it must be outside of the range. So something like, this will be valid. So yeah, those are all the rules. With that, let's just begin solving. Alright, so what shall we start with first? The more constrained ones are definitely the ones with bigger ranges. So for example, the 3 8s and the 1 6s all have a smaller set of digits outside of its range because they themselves are further apart. So for example, 1 and 6 only have 7, 8, and 9 that are outside their range. The 8 here resolves that for us. 8 must go there. For the 3s to 8s, the digits outside their range are 1, 2, and 9. And those are the only digits outside of their range. So those 9s mean 9 must be in the middle. This digit can't be a 9 either. And this 2 means that digit can't be a 2. We could probably do similar stuff with those digits. But because those are only 4 apart, there are a lot more, there are slightly more digits that are outside of their range. For example, 5 to 9 have the digits 1 to 4 outside of their range. So I don't know if, we're supposed to do that. I guess that is somewhat helpful though, because along with this, that forms a quadruple consisting of digits 1, 2, 3, and 4. The remaining digits therefore must be 6, 7, and 8. And that digit can't be 8. Could probably do something similar as well, maybe. This would, this would have to be 6, 7, 8, or 9. Oh, and interestingly, all these 9s here remove 9 from all of those cells, so they must be 6, 7, and 8 as well. And this 8 tells us that an 8 is out there. Awesome. Okay. So we're slowly, I guess this is more about slowly like narrowing down your options until you get a final digit. For this range, it's similar to this, where this has to be 1, 2, 3, or 4. This digit can't be 1, 2, or 3 actually because of this triple here and the 3 here, so it must just be 4. Which definitely helps. It's the same thing here, right? Between 9 and 5. Well, outside of the range of 9 and 5, you only have 1, 2, 3, and 4. Which gives you a quadruple here. Does that help? Yes, 9 in this box must therefore only go in that cell. Cool, cool. I want to say... Well, I can remove 8 from that cell and place an 8 here for that reason. I think it's a bit easier to say where does 8 go in this column then, because these 8s remove 8 from those cells, so 8 has to go here. I was gonna say that 8 is one of those cells, which means 8 is not there. That's also valid because of this 8, but not gonna be very helpful. Alright, another triple over here would be 2, 3, 5, I think? 2, 3, 5. Yes. Oh, and this cell can't be 2 or 3 because of that, so it must be a 5. So that gives us a triple over here consisting of, I think, 7 and 6. Yeah. That was not in order, but hopefully that worked out. 9 here resolves the 7, 9 pair, which resolves the remaining 6, 7 pairs. Alright, all of them in fact. This one also is resolved. So in fact, in this box, 7 coming in those cells, it must be there. This digit must be 6 and 8, and 6 resolves that. What else do we have? This is 2, 3, and 4. Can we resolve that in some way? I don't think so, not right now. Okay, what about this? Do we have anything for that? Like, what range is this? This is 1, 7, 8, and 9, right? Those are the only digits outside of the range. But because this can't be a 9, we can remove that. 7 means that can't be a 7 either. And this can't be an 8 because of the 8 here. That doesn't really do anything for us, but okay, I guess that was a good deduction. Or, yeah, that was fine. Okay, we have another pair here. I'm not seeing pairs today. This is 4 and 5, and that 5 resolves that. Oh, this 1 means there's a 2. Wow, this was there from the very beginning, wasn't it? Well, yeah, that resolves all of this. And now those digits can be a 1. Yeah, it was from the very beginning, and I never saw that. Okay, let's keep moving. That's a triple over here. This is 1, 3, and 4. This digit can't be 1 or 3, so it must just be 4. This is therefore 1, 3 pair. That makes this a triple, consisting of 7, 8, and 4. 4, 7, 8. That digit can't be 7 or 8, so it must be a 4. And 7, 8 pair here. Oh, 3 here removes 3 from those cells. I didn't see that either. This forms a 2, 3, 4 triple, I think. No, 4 is not in that cell. So in fact, 4 here must be here. This 2, 3 pair means this cell can't be a 2, so that's a 1. And so that digit is just free for us, I think. That is a 5. So this has to be a pair consisting of 2 and 6, and that resolves. We got a lot more triples here, but firstly a pair, which has to be, I think, 3 and 4, which is resolvable. Now those digits are, I think, 1 and 2, which we can fix. And those digits are therefore 8 and 9, which we can also fix. Cool, that digit is free, and it is a 3. So 3 is not there. Does it do anything? It gives us another triple here, so this has to be, I think, 4, 6, 7. Yeah, none of those cells can be 6 because of the 6 is up here. So 6 has to be here. 4 resolves this remaining 4, 7 pair, which gives us everything else, I think. 7 resolves to 7, 8. And this 4 gives us a 1 here, so that's a 9. Never mind. Oh yes, this 4 resolves this 3, 4 pair. Did not see that either. That gives us a 1, 3 here, which resolves this 2, 1. Nice. 3, 4 here means that must be a 2. That resolves all of this. I hope I'm not going too fast. I think I might be going a bit fast here, just by resolving all the pairs that I'm seeing. If this speed is a bit too high for you, I can slow down if you just, told me in the comments, I guess. Alright, so what do we have here? This is 2, 3, and 5, I think. 2 come in those cells, so 2 goes up here. This has to be 3, 5, which means 5 goes here and 3 goes here. We're almost done, actually. 7 resolves this 6, 7 pair, firstly. Those just must be a 1 and a 6, I think, and that 1 resolves. And the last 3 digits are 5, 7, and 9. There we go. So 7's firstly must be here. The 9 resolves this remaining 5, 9 pair, meaning that's a 9, and 5 goes here. Solve the puzzle in 6 minutes and 57 seconds. Awesome. So yeah, that is Lockout Lines by Clover. Hope you enjoyed this video. I'll see you guys next time. Bye bye.